Hi! In this video tutorial, we will walk through the process of building an HTTP service in Rust from scratch. This tutorial is designed to be beginner-friendly, so even if you are new to Rust or HTTP services, you will be able to follow along. We will be creating an HTTP server that serves static content directly from the file system. To help you understand the concepts, we will also compare our Rust implementation with Python's built-in HTTP server. It is included in Python's default installation. This side-by-side comparison will give you a clear idea of what we will be doing and how Rust can be a valuable tool for web development. By the end of this video, I hope you will have a solid understanding of how to create a basic HTTP service in Rust and be well equipped to explore more advanced web development topics with this powerful programming language. Let's get started. So to begin with, let's utilize Python's built-in http.server and demonstrate its functionality. Now I am inside the directory for this demonstration. Inside this directory, there's a text file and a subdirectory. The subdirectory contains an image file and a soft link to this image file. We can use Python's HTTP server to display the content of this directory. To launch the server, type python-m http.server. By default, it is using the port 8000. So the service is launched. It will display the content of the directory while it is launched. See, the trailing slash indicate the item is a directory, and the files are without the trailing slash. If we click on the file, the content should be displayed on the browser. We can enter into the directory. The trailing @ symbol indicates the file is a soft link, and we can also click on it to display the content. I hope this Python demo has given you a good introduction of the functionality we will be building. Now let's transition to the Rust side. We will be using web frameworks to develop our service. There are actually several frameworks available in Rust. After some investigation, I chose to use Axum for several reasons. First of all, it's very popular. It has the highest downloads among all the web frameworks, although it is not the oldest one. It is also very well maintained. The commits are very active. Not many open issues, a lot of are closed. This indicates the code is actively maintained by the team and they are very responsive. And the third reason is that it's very easy to learn with all these examples. Of course, there will be hello world, but also very pragmatic and helpful ones, such as dealing with Postgres, how to set up the metrics, how to set up the tracing, and how to use WebSockets. Lastly, the code is in the good hands. It is maintained by the Tokyo team, which I believe is very technically strong. Now let's set up the development environment. If you haven't installed the Rust toolchain yet, go to the official website and follow the instructions. Once the installation is completed, you should have access to the cargo command in your shell. To create the project, let's use the command cargo new, followed by the project name. In this case, let's use http-server. The command is going to create a new directory for the project. For the actual coding, I use Rust Rover because I'm accustomed to the products of JetBrains, but you can use your favorite editor for development. Here I open the project in Rust Rover. run it, let's use the command cargo R. R is short for run. It should print a hello world to the console. The service we are going to build isn't very complex, but it is more involved than a simple hello world case. To approach this, let's carefully plan our development process by breaking it down into smaller and manageable steps. We will complete one step at a time, thoroughly test it, and then proceed to the next. This incremental approach will help us build our service very effectively. Let's outline our plan step by step. In the first step, we want to be able to launch the Axum server. This includes add the dependency. Write the example and compile it and run. The next step, we would like to be able to handle the request for the directories. And we have two cases to handle here. One is the root directory. The second is the subdirectory. And the last step, we want to handle request to show file content. And we need to be able to determine the MIME type. And also return the file content. Next, let's attempt to compile and run a basic Axum service. The create page conveniently provides a usage example. We will examine the code and comments to understand what it does. This is also an excellent opportunity to familiarize ourselves with high-level concepts in Axum. I have copied the code snippet into my IDE, which makes it convenient for us to reference and explore the documentation of the methods. In an Axum service, the central component is the router. It directs various HTTP requests to the respective handler function. The router can be created through this new method, and then we can add various routes to the router. This route method accepts two parameters. The first one is the path, the second one is the method router. Let's first take a look at the first one. A path is a string of path segments separated by slash. And each segment can be either static, a capture, or a wildcard. The static path basically requires that the incoming request must match exactly as the path string. And the capture and wildcard meet the requirements that we want to use the path parameters. In cases we know the pattern of the path, then we can use its capture one and use the column ID, for example, to extract the user ID. But there are also use cases that we don't really know what the pattern will be like. And in these cases, we can use the star key to match various type of segment. In our development of the server to serve the static content from the file system, let's think about what type of path we should use. Since we need to serve the content from the current directory at the root, so we will be using this static path. And since we don't really have the prior knowledge of the paths of the files or directory, so we would better use its wildcards, so it can match all the possible paths of the files and the directories. Now let's focus on the second parameter, which is the method router. Method router is the struct that should receive the request if the path matches path. This one is straightforward. If any of the HTTP request path is matched by the path defined here, it will be directed to the method router. It is commonly be a handler wrapped in a method router, like get. The second comment is a little bit difficult to follow. I think what it really means is that it will be a handler function wrapped in a HTTP request method. The HTTP request method can be get, post, add, options, put, delete. And the handler function is usually an async Rust function that is doing the real business logic. So far, we have finished our first task. We have launched the Axum server by adding the dependency of Axum. We also compiled and run the Axum example service. It's time to start the second task, to handle requests to list the directories. There are two cases. One is to handle listing the root directory. The other is to list the subdirectories. And as we have learned that to handle a request, we need to figure out the path and also the corresponding method router. For the root directory listing, we will use the path slash because it's the root. And for the method router, we need to use get. And then we define some function, Rust function, to list the root. Actually, root directory wouldn't be correct here. It should be working directory. And as we have learned that to define a route, we need to determine the path, the method router. The path for the working directory would be slash. And the HTTP method would be get. And let's use the function name list wd for the handler function. So let's also update the comment. As for the return value, because the content is not predefined, so we cannot use the static string here. It should be a string. And the string would denote the HTML document. Since I'm not a front-end engineer, templating the HTML document is quite a challenge to me. So I decided to ask ChatGPT for help. So this is the question I asked ChatGPT. In Rust, without using any crate, template HTML document as a string. The content is the list of the items in the directory. And here's the response. Actually, it already looks quite reasonable in its first attempt. It defines the directory path, then try to read the content of the directory as entries. Then it defines the string to contain the content of the HTML, iterate the entries, adding each one of them as a list, and then wrap it up. Let's try it out. Firstly, I want to verify if this is a valid HTML document. So I will only copy a fraction of this. Let's rerun the server. It compiles and runs. This is not what I had expected. So what would be the issue? I think the content is faithfully reflected, but the problem is that the browser is not formatting it. I suspect that the issue is with the content type. So I checked the value of the content type. It is text plain. In order to let the browser format it, I think it should be text HTML. After resolving the content type issue, let's go back to where we left off. We still haven't added any entry of the directory to this HTML string. And while I'm reading the answer from ChatGPT, I found an issue. It is using the standard library file system module. However, since we are using Tokyo here, and which requires any heavy function to be async, we should use the module from Tokyo. So I asked ChatGPT to use the Tokyo one instead of STD one. So here is the answer. The main difference is that we need to add the await to the end. Let's try out the code from ChatGPT. I pasted this code here, and there's an error from the compiler. It says that the question operator cannot be used here because the function is now returning neither result nor option. It totally makes sense. However, since I do not want to cram too much information into this short tutorial, let us just unwrap everything to save the effort to define our own arrow type. Okay, now the compiler is happy. Next step is to iterate the entry and add each of them to the HTML list. There's another complaint. It says that the redirect is not an iterator. After some investigation, it turned out that ChatGPT is very wrong here. The entries from the Tokyo's version is actually cannot be used in this way. Entries needs to be defined mutable because we are consuming it. Let's try it out. Great. Now we see the list of the content in the directory. Now let's compare the result of our service with that of Python's. Let me launch the Python's http server. As you may see, there are two main differences. In this title, Python's version is more user-friendly because it tells where the current directory is, while we are missing this information. Another main difference is that we need to use the hyperlink here instead of the plain text. Now let's patch these two missing parts. The first one is the path in the header. So let's name it header path or URL directory path because it should be from the URL. And for working directory it's the slash. And I start to sense some bad smell of the code because we start to hard code the variable values. So let's add a to-do here. This directory path should be from the request path. Then once we have got the URL directory path, let's use it in the header. So let header be formatted. Push string expects a reference. Let's rerun the server and see if it works. Okay, the first patch is done. Let's patch the second one, which is use the hyperlink for each entry. So how do we format the hyperlink? Hyperlink syntax. So it should be formatted in this way. And the URL can be the directory path concatenated by the entry name, and the text would directly be the entry name. So let's replace this with the link. Okay, we can see that each entry is formatted as the hyperlink, and if we click on it, the corresponding URL is also correct. The page of the subdirectory is blank, so this naturally leads us to the next unresolved issue, which is to handle the request to the subdirectory. Such requests cannot be handled by this route because the path does not match. Remember, there are three types of paths. The first one is the static. We have already used it for the root. The second one is the capture. It is useful when we already know the pattern of the path. And third one is the wildcards. In our case, because we don't really know what the pattern will be like, we should be using the wildcards to match the directory path. Here we can find an example of how to use it. Serve asset. So the serve asset can extract the segment by using this pattern. Let's add another route to handle the wildcard use case. We will still be using the get http method and use a new handler function. And it will take one parameter, which is the Axum path. And what will it return? Since in this case the path can either be a directory, in which case we will be returning HTML. In other cases it will be a file, and we will be returning different content type based on the file type. And in Axum, how can we handle the case returning different response types? And it suggests that we should be using the generic type response. Now let's test if our request to the subdirectory can be handled by this new route. In order to test it, let's just return some magic page. Let's start the server and go to a subdirectory. Okay, so we get this magic page, which means that our request to the subdirectory is handled. And if we go to a file, it should also return the magic page. Our next step is to implement this handle path function. And notice that this path can actually be not only the directory but also files. So we need to distinguish these different cases. So let's firstly convert this URL path into a file system path, which would be prepending the // path. Then let's call some standard library to tell the metadata of this path. And such questions are great for ChatGPT. So I will just use it here. And do some cleanup. Since the path here is from the Axum, we need to use a more specific namespace. And here it will be the Tokyo FS. And as always, we just unwrap all the results. And for all these different cases, let's return not implemented error. And how we do that? Okay, so we just need to use this. Request not handled, and if this file would say file not handled. What would be the other case? A metadata can be is direct, or it is file. What else can it be? It can also be symlink, and I think we should treat symlink the same as file. So let's just add it here. And for all the other cases, we should admit that. Let's see if this works. So we have target, which is directory, and directory is not handled. Check. The cargo file is a file, so file or link theme link is not handled. How about we just manually link something and see if it is correctly handled. Symlink is also handled. Great. Let's continue our journey. We have finished the handling request to the working directory, and we have prepared ourselves by adding a route to handle requests to the subdirectory. Now it's time to finish this part. And since we have already finished most of the business logic in this function, let's just do a little bit of direct refactoring so it can also handle the request to the subdirectory. And the input parameter would just be a pass, right? And the return value would still always be a HTML. And the pass can be two cases. If the pass is a dot, or it can also be a subdirectory, such as if pass is equal to then we list Actually, since it is a refactory, we should just copy most of the logic from this function. Right, and what we need to determine is what is the form of the URL directory path. And if the path, directory path is equal to the dot, then it should be a slash. Otherwise, it should be the directory path is the prefix stripped, and
Then we don't need it. Then in this listed working directory, we just need to call the list directory function, and it will be let's see if this works. Okay, the root page is still working, and let's see if we go to the subdirectory. It is still directly not handled. Sure, because we haven't called the right function yet. So let's call the list direct, and it needs to be converted into response. Great! Now we can handle the request to the subdirectory. What's next is to handle requests to the file. It is time to implement handling the request to the file or symlink. And as we have planned, we need to determine the MIME type of the file. And here we will just use the create MIME guess. It is very handy because it can guess what the MIME type should be based on the extension of the file. So let's add the dependency to our project. And then use the create to have a guess. And because it's written a option, it indicates that this MIME guess create may not always get a answer. So we need to use a default MIME type. And for that, I think we should use the octet string to return the raw bytes of the content. So we have got the MIME type, and for the status code we should be returning OK, and then it will be the content of the file, and we should just return use the standard library to get the raw bytes of the file. And for this we will again ask ChatGPT for help. So the question would be, use Tokyo, read the raw bytes of a pass. So it will just use the fs read to read the file into raw bytes asynchronously. So here, Then it's time to build the final response. Right, and for the final response, we will be using this builder pattern here. Well, we can set the status, the header, and the body. Header would be content type and use the type string for the value, and then for the status would be okay, right? And the body from the bytes. We're still complaining. I need to return it. Let's launch the server and see if it works. So the server is relaunched. So it downloads the cargo log. Let's see. What about this JSON file? It starts to give me error. Let's see what's wrong. It says no such file or directory from the line 39. And 39, we are trying to get the metadata of the path. And it says this path does not exist. Let me add a breakpoint here and try to debug it. I see. So the path is obviously wrong. It should be /target /rustcinfo.json. But here, it replaced the slash with the dot. And so the bug indicates that we missed some slash here, especially for the case of this subdirectory. And in this case, if it is not the working directory and we just strip the prefix, yeah, we are missing the slash at the end. And we can just, here we can add another step by appending the slash to the end. But we can probably also combine the logic, right? Because if we stripped the dot of the working directory, it will be an empty, and we append the slash at the end, it will still be this slash. So let's try to consolidate here. First, we strip the dot. Second, we try to reformat it by adding the slash to the end. Let's see if this works. Okay, now you can see the path is correctly formulated, and I even noticed that the JSON is very nicely formatted by the browser. Let's test more cases target is fine. This is a file. Okay, if it is a file, it's downloaded directly. And what's going wrong here? Another error, no such file directory at line 39. Again, let's just run the debug mode and see what's happened.
After some investigation, I found the root cause. It is with how I formatted the link. If the path is a directory, I should append a slash to the end. Otherwise, it is not needed. I also made a mistake with the interpretation of the value of the href. It turned out the value does not need to be the value from the root. It just needs to be the value from the current URL path. Therefore, I don't need to combine the URL directory path with the entry name. I just need to use the entry name as the value for the href. So I correct these mistakes and relaunch the server. Let's see if it works. Now it works as expected. As we conclude this tutorial, let's recap our achievements. We successfully utilized the Axum framework to create a HTTP server to serve static content from the file system. Along the way, we gained some valuable knowledge into the fundamentals of the Axum framework, such as adding new routes to handle requests, extracting path parameters, and how to build the responses. The core logic is implemented by leveraging the Tokyo library to efficiently manage files and metadata. I hope you have learned a lot in building a Rust-based HTTP service, and you have been prepared for further exploration in this area. I upload the code to GitHub and attach the link to this video. You may check it out and play with it. If you are interested, there are also some improvements we can do about this project, and you can try it yourself. For example, we can try to add the logging and the tracing for the request. We can also add the command line arguments so users can specify the port to use. We can also make this program more efficient by streaming the file content, because now we are reading all the file content into memory, which may not be very efficient and even crash the program. If you want to understand more about Axum, I'll provide two links here. The first one is a YouTube video, which tells you more detailed knowledge of how Axum works. And also there are a bunch of examples from the Axum project that you can follow. Thank you very much. See you next time.